All right, welcome back to your online geometry course. We are jumping into the next section, which is going to be on special angles. Okay, so we've already talked about some different geometric figures, and we came up with precise descriptions or definitions of them. I want to make sure you guys are able to give a good description of these. Don't say a point is a dot. Don't say a line is something you graph. I want you guys to know the precise descriptions of them. So just to remind you, let's run through. A line segment is going to be a part of a line consisting of two endpoints and all the points in between. A ray is part of a line with one endpoint going in one direction. A line is a straight path of points going in opposite directions forever, and it has no thickness. A plane is a flat surface that goes in all directions forever. It has no thickness. A point is going to be a unique location with no dimension. The vertex, we know what the vertex of an angle is. Coplanar are going to be points such that a line could be created to contain all of them. Actually, it's a plane, so a plane could be made to contain all of your points or lines or whatever you're talking about. Collinear means points such that a line can be created to contain all of them. So just make sure you guys know these. It's important to know the precise descriptions of these figures. Okay, we talked about congruent versus equal. Congruent is talking about the actual object. And equal is talking about their measures. So now what we're doing is we're going to be talking about some different angles. Okay. First things first, we're going to talk about adjacent angles. Here's an example of adjacent angles. Right here. So if we had these two angles, 1 and 2, those would be adjacent angles. Okay. Let me show you non-adjacent angles. This angle and this big one would not be adjacent angles. Other ones that would not be adjacent angles, this one and this one up here. So if we had to come up with a good definition, part of us says just write two angles that are next to one another. But both of these angles are also next to one another, and they're not adjacent angles. Then you might want to say just two angles that share a side, but this one also shares a side, and they are not adjacent angles. So we have to put it all together. Here's a good description. Adjacent angles are two angles that share a side and vertex, but no interior points. What does that mean? Well, if we had this angle, these would all be points. If we had this big angle that kind of contained it and it shared a side, it would have points. Notice how they share points. If you look over here, any point inside of this cannot be inside of that one. All right. Next one, vertical angles. You use vertical angles a lot in geometry. Here's an example of vertical angles. 1 and 2. Those are vertical angles. 3 and 4 are also vertical angles. Okay. So let me show you an example of a non-vertical angle. Here, this angle, and then that one. So you're probably tempted to just say two angles that are across from one another. But are these ones across from one another? Yes, they are. So how could we talk about these angles? By the way, some books call these opposite angles. The vertical angle is a little confusing because some of them are vertical and some of them are horizontal, but they still call them vertical angles. Well, our definition for this are angles whose sides are opposite rays. Let me explain that. Let's look at 1 and 2. Do you see 1 has a side that is that ray? You see 2's side is an opposite ray? Do you see 1 has this as one of its sides, that ray, and 2 has the opposite ray? It's basically a way of saying when two lines intersect, you end up getting vertical angles. Okay? So the next one is complementary angles. Complementary angles are two angles whose sum is 90 degrees. So let me show you an example. Let's say you had this angle, and they come together to make a right angle. Those would be complementary angles because they come together to make 90 degrees. So next, supplementary. Supplementary are two angles whose measure is what? 180 degrees. Okay, show you an example. This was 120 degrees, and floating over here was another one that was 60 degrees. That would be an example of supplementary angles. A lot of people forget which one is supplementary and which one's complementary, 90 versus 180. Well, you have a C for complementary and an S for supplementary. One of those makes a 9 for 90 and one makes an 8 for 180. Supplementary makes an 8 for 180. Complementary makes a 9 for 90. That's the way you can remember it. Okay. The next one is a linear pair. Linear pair are going to be two adjacent supplementary, let's say sup angles. So these right here are supplementary, but since they aren't adjacent, they're not actually sharing a side, then they wouldn't be a linear pair. Here is an example of angle 1 and angle 2 are going to be adjacent, and they are going to be supplementary. Adjacent and supplementary, that makes it a linear pair. Okay, so just make sure you understand. Supplementary could be angles that aren't attached. They're not adjacent, but linear pairs make a line and they are going to be attached. The next one is angle bisector. An angle bisector is going to be a ray that divides an angle into two congruent angles. So if you had this angle right here, if I went over and I made a ray coming off that split it up into two congruent angles, then this ray would be called an angle bisector. Okay, so it's important for you guys to know those definitions. You might be tested on them word for word. Okay. So when we get down here, let's look at some examples. I'm going to give you an angle, and you have to figure out another angle that is either adjacent, a vertical angle, supplementary, complementary, or so on with that angle. So let's say we are talking about angle AFC. Angle AFC. What is an adjacent angle with angle AFC? What is an angle that shares a side and a vertex with AFC? Well, this angle over here shares a side and a vertex. So CFD, angle CFD. Okay, vertical angles. Let's go ahead and talk about angle BFA. Vertical angle with angle BFA. BFA, BFA, we're talking about this one right here. What is an angle that is across from that angle? And the sides are opposite rays. This one, right? This angle and this angle over here. So that would be angle DFE. It would be vertical angles. Okay, supplementary angles, two angles that come together to make 180 degrees. Well, you could have done two right angles together, but I'm going to be creative. Let's say we had angle CFD. What is another angle that comes together with CFD to make 180 degrees? Well, a line is 180 degrees, so it'd be CFD. Angle CFB. Those two come together to make a line, and a line is 180 degrees, so it makes sense that it would be supplementary. How about complementary? Two angles that make 90 when they come together, their sum. Angle AFC and angle what? What is another angle with AFC that comes together to make 90 degrees? Angle CFD. See how this angle and this angle come together to make 90 degrees because we have the little box which means 90 degrees? An angle bisector. An angle bisector, for your answer to be reasonable, it better be a ray. What is a ray that is cutting an angle in half? Well, angle AFD is being cut in half by FC. FC. Okay? Ray FC. It's important for you to know if your answer is reasonable. For example, if I said these two lines intersect at what? We know two lines intersect at a point if they intersect. So our answer should be a point, unless the two lines were the same line and they were on top of one another. All right, how about a linear pair? Two angles that come together to make 180 degrees, but are also adjacent. That would be angle CFD and angle CFD. It's the ones that we already talked about that are supplementary, and angle CFB. All right. Page. So the next page. Here we go. Pencil, options, stroke. All right. So on this problem right here, it asks us to try to make a drawing of this figure, of a figure that has all of those characteristics. Well, I'm going to start with the angle ADC is bisected. So angle ADC is bisected. Angle ADC, ADC is going to be bisected. Now, for some reason, this thing just loves going over and changing how thick my pen is, and it drives me nuts. Okay, so now we're here. ADC is going to be bisected by DB. D going out to B. And it's a bisector, so I have to put the congruent marks here to make sure you know that it is bisected. It just so happens that by making this, I do have ADB, ADB, and I have BDC, which are going to be adjacent. So yay, check mark, got those. Now I just need to make a vertical angle with BDC. BDC is going to be a vertical angle with EDF. So let's just make a vertical angle. I'm going to continue that out as a line and this out as a line. Now those ones are vertical. And now I just need to name it. It's EDF. So EDF. Check. Okay, we covered all our bases. We've got all the requirements in that. So we are done with that one. Let's move on to the next one. The next one says you have complementary angles. Two angles are complementary. If BMC is 6x plus 1 and CMD is 4x plus 11, then what do you get? Let's just draw it out. We have EMC and CMD are going to be complementary, meaning they come together to make 90 degrees. Technically, you didn't even need to draw this because you already know that one angle is here and the other angle is there. Are we setting them equal to one another, or are we setting them equal to the whole? Well, since we know one and the other, and we know the whole is complementary, so it's 90 degrees, we can add them together. 6x plus 1 plus 4x plus 11, and that is going to give you 90 degrees, which gives you 10x plus 12 equals 90 degrees. When you solve that minus 12, you get 10x equals, let's see, 80, 78. And then you would divide by 10. And you would divide by 10. Okay? So it's 7.8. That's what x is, and it's only asking for x. We don't have to substitute it back in. All right, let's move on to the next one. It says these two angles are supplementary. Supplementary, that means 180 degrees. AD or ABC is 20 degrees. 20 degrees. And CBD is 15x plus 10. Well, if they're supplementary, that tells us that the whole composition of the two angles is going to equal 180. So I know I can add those together, getting 15x plus, well, we had a 10 and then we had a 20, it's 30, equals supplementary 180. Ching. Minus 30 minus 30, you get 15x equals 150. Divide by 15, and you end up with 10. Does it ask you to substitute back in? Nope, it just asks for what x is. Let's keep on cranking. Okay, next one. DB bisects that angle. Let's just draw it. Actually draw it, don't move the thing. ADC is bisected by DB. It says that ADB is 8x minus 2. BDC is 6x plus 38. Okay, now we have to ask, are we adding them together and setting equal to the whole, or do we have two congruent things that we can set equal to one another? What does bisect mean? It means that you end up with two congruent angles, meaning those are congruent. So you do know that 8x minus 2 equals 6x plus 38. When I subtract 6x and subtract 6x, I get 2x. When I add 2 and add 2, I get 40. Divide by 2, and you get x equals 20. Notice there is algebra in geometry. Okay. Next thing we have to talk about, we already talked about what vertical angles are. We have to talk about what the theorem is, meaning what is special about vertical angles. What do you notice about this angle and that angle, and this angle and this angle? 4 and 2 are, and 1 and 3 are congruent. That's the rule, the theorem that we're going to use a lot. Vertical angles are congruent, meaning if this one was 100, or let's say that one was 80 degrees, what would this be over here? 80 degrees. If this was 100 degrees, what would this one be down here? 100 degrees. They are congruent. We're going to use that. So in this problem, you take a look at it. You're like, well, what do I have? Oh, I've got vertical angles. What do I know about vertical angles? They are congruent. So what am I going to do if I know things are congruent? Oh, when they're congruent, their measures are equal, so I can set them equal to one another. You end up with, okay, x equals 40. Okay, the next one, we look at this. You always ask yourself, what am I working with? Am I working with supplementary angles, complementary angles, vertical angles? When you find out what you're actually working with, it'll guide you along in figuring out how you're going to do the problem. So here we have a linear pair. Linear pair are supplementary, which means those can be added to be 180. So I could say 10x plus 2 plus y equals 180. But how many variables am I going to have? 2. So I can't do that. Let's look at this first. These are vertical angles. Vertical angles are congruent. If they're congruent, you can set them equal to one another. 10x plus 2 equals 8x plus 22. Minus 8x minus 8x is 2x. Minus 2 is 20. So you get x equals 10. What do you think you're going to do now? Well, now we can go over and figure out what this angle is. 10 times 10 is 100 plus 2 is 102. If I knew this was 102, and these two come together to be 180 because it's a line, basically. So how much do we have left for y if this is 102? This one is going to be 78 degrees. All right. So some of these problems are a little confusing. Like I said, in geometry, it's not so much just do exactly the steps that I do. It is think. Whenever you have, let's do this. Whenever you have congruent angles, or congruent segments, you can set them equal to one another. Okay. When you have part and part, you can add to be the whole. When you have supplementary, you know you're going to be able to add them together and set equal to 180. When they're complementary, you know you're going to be able to set them to add them together and set them equal to 90. So, one more page. Let me make sure. Okay, so on this problem right here, on the last page, it says, knowing that this is 40, figure out what x is. This is basically starting you off and thinking logically to do a proof. Well, just start filling things out. If we know this is 40, do we know this angle right here? Are they do they come together to be 90 degrees? No, not necessarily. We don't know that. So start looking around. Do you see any supplementary angles, linear pairs, vertical angles? Do you see, what else? An angle bisector? See any of these things? Oh, well, check this out. If this is, well, it says FB bisects angle AFC. AFC. This one is going to cut it in half. I can't do anything with that. In geometry, you just start filling things in. So if this is 40, then what's this? This is 40. Well, we didn't, I mean, maybe that'll get us closer to where we need to be. If this is 40, how am I going to do this? Oh, look at this. All three of these angles come together to be 180 degrees. So 40 is already accounted for. What is left over for right here? 140. If that's 140 and this thing right here is a bisector, then what are each one of these? They must be 70 and 70 because bisector cuts them in half. Now if this is 70, what's this going to be over here? Those are vertical angles. 70 degrees. So you had to go through this whole process to get there. That and that are vertical angles, so I could say that is 40. Whatever's left over with the line, that's 140 degrees. Okay, well, half of it must be here and half must be here. And if that's 70, then this one's 70 because they're vertical angles. All right, we got one last problem, and that's this. Look at it. Do you see linear pairs, vertical angles? Do you see anything? I see vertical angles, so I know that those are equal. 3 are congruent. 3y is going to equal 3x plus 12. Can I solve that? No. But we have this other one also that's another set of vertical angles. 2y is going to equal 6x plus 4. We can't solve either one of them because they have two variables. Do you remember how to solve for two variables if you have two equations? Substitution. So let's go ahead and solve this. Divide by 3, divide by 3, divide by 3. You end up with y equals x plus 4. Do you remember how to solve by substitution? You grab what y equals and substitute it into the other. So this is 2 times x plus 4 equals 6x plus 4. You also could have gone over and solved this by elimination. 2x plus 8 equals 6x plus 4. Minus 2x is 4x. Minus 4 is 4. So you get x equals 1. What do you do once you have one of your variables? Substitute into the other place. So y must equal 1 plus 4. That's 5. All right, so the most important thing you need to know is that when you have angle bisectors, you're going to end up with congruent angles, which you can set equal to one another. When you have a linear pair, you're going to have two angles that come together to be 180 degrees. When you have vertical angles, they're going to be congruent. You can set them equal to one another. So there you go. We've talked about a bunch of different angles. We've talked about how we can use those angles. I hope this all makes sense to you. Let me know if you have any questions, and make sure you do your homework in Math Excel. Thanks a bunch.